Example 2, common factor the following polynomials. So again, we don't know what how to factor trinomials. We haven't learned that, but we need to know that in order to properly completely factor something, you need to know how to common factor, which is why we're doing this part first. So what can these all be divided by? The biggest number, 3. And then basically the easiest way is to look at all the x's and which is the smallest one, an x squared. So all of these you can take out an x squared. You know that they would all have an x squared in there. So we've common factored, a 3x squared. So we're going to divide out a 3x squared, and there's some stuff remaining. 9 divided by 3 is 3. The x squareds are gone. 12 divided by 3 is 4. There's one extra x left up top. And negative 15 over 3 is negative 5, and there's 2 x squareds left on top. So one of those is left, and both those are gone. 2 of these is left when both of those are gone. And that is considered, we've taken out the biggest common factor. So keep going here. These can all be divided. The very first one, by the way, is negative, so we'll make sure to divide them all negative. 4 looks like it's the largest one that can come out here. And then of the x's, x squared, x squared, and x squared. The smallest is an x, so we can take out an x. And then y squared, y1, y squared, y1 is the smallest. So negative 4xy, we'll take that out, and we will be left with negative 8 divided by negative 4 is 2. The x's are gone, and there's still one y remaining on top. 12 divided by negative 4 is negative 3. There's an x remaining on top. Negative 16 divided by negative 4 is a positive 4. There's an x on top and a y on top. And so that is considered fully factored. Let's take a look. These can all be divided by 5. And x squared, x is the smallest of all of them, so we can take that out of all of them for sure. Y cubed, y squared, so you can definitely take a y squared out. That's the smallest of all of them. Z squared, z cubed, so z is the smallest of all of them. So we can take out a 5x, y squared, and a z, which is a little bit extreme here. 10 divided by 5 is 2. X's are gone. There's a y3, y2. There's a y remaining on top. And z2 over z, there's a z on top. Minus 20 over 5 is 4. There's an extra, x squared over x, there's an extra x on top. The y squareds will cancel, and the z's will cancel. Negative 15 over 5 is a negative 3. The x over x is gone. The y squared over y squared is gone. And the z3 over z leaves us with a z2 on top. So this is considered fully factored. I'm going to keep going here and finish these last 3 off. These can be divided by 2. So 2 can come out of all of these. x4, x3, x2, and x. The smallest is an x, so we can definitely take an x out of all of them. So if I take a 2x out, if I divide a 2x out, 2 over 2 is 1. x4 over x is an x3 remaining. Negative 4 over 2 is negative 2. x3 over x is an x2 remaining. 2 over 2 is 1. x2 over x is an x remaining. And then negative 8 over 2 is 4, and the x's are gone. So this is considered fully factored for common factoring. Now this one, 3? Can I take a 3 out? 3. I have to take a negative because the first one's a negative. So I'll take out a negative. I think 3 is what's common between all of these. x3, x2, x2, x2. So x2 is the smallest. y2, y, y2, y3. So just a y is the smallest. I don't know why I didn't write the x squareds here. X squared y, x squared y. So negative 3 x squared y. And then what am I left with? Negative 15 over negative 3 is 5. I have an extra x on top and an extra y on top. 12 over negative 3 is negative 4. And I have exactly the same x2, y, and y, so those are all gone. Negative 9 over negative 3 is a positive 3. x2's are gone, there's an extra y on top. Minus 6, the x's are gone, and there's 2 y's on top. So that would be considered, we have taken out the biggest common factor. This is very repetitive. I don't know why I have so many questions. It's exhausting. So take out a 3 out of all of these. x4, x3, x2, and x. So x is the smallest. Y, no y. Okay, well, no y and y. So there's no y's that are common. No z, 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 no z. So there's no y's and there's no z's in common. So only a 3x can come out. 9 over 3 is 3. There's 3 extra x's, x cubed on top, and there's a y. 6 over 3 is negative 2. There's an x squared on top and a z. 4, there's an extra x on top and a z. And negative 1, and there's a x's are gone, an extra y. Okay, so hopefully that's good practice for how to take out a greatest common factor. And we will now do, we've already done 2 videos here, but we're now actually going to get into how to factor trinomials in the next video.